Follow the steps outlined below to factor this expression by GCF factoring. Let's see what that means. First step, find the greatest common factor of the expression above. You may recall that the GCF is the highest number that divides exactly into two or more numbers. The GCF may also include variables and exponents. Okay, so this is our expression, 10a to the second minus 15a to the third. We're looking for the highest number that divides into two or more numbers. So if we're looking at 10 and 15, the highest number that divides into both of them is 5. Okay, but the GCF may also include variables. We should notice that both of these terms have a in it, a to the second and a to the third. Now, let's think about what that means. A to the second, let's come over to the side. A to the second means that we have a times itself twice. A to the third means we have a times itself 3 times. So both of these expressions have at least 2 of them to divide out. Therefore, we can include a to the second as part of our greatest common factor. Okay, so we did the first thing, which was we found the greatest common factor just by figuring out what would go into both parts, and it's 5a to the second. Okay, step 2. Write the GCF, okay, 5a to the second, and prepare 1 parentheses for the other factor. Okay. Next, we're going to divide each term of the expression by the GCF to fill the parentheses. So again, our first step was figuring out 5a to the second as being the biggest thing that could go into every part. Next, we opened a parentheses to prepare for another factor. And last, we're going to divide. 10 divided by 5 is 2. Anything divided by itself, so a to the second divided by itself cancels to 1. Okay, bring down the subtraction sign, or negative 15 divided by 5 is negative 3, either way. And then last, in order to divide powers of the same base, we keep the base, the a, and for division, you subtract exponents. So we get a to the first, or just plain a. And this is our expression in factored form. So what you should notice is that factoring is the opposite of multiplying, right? And GCF factoring is the exact opposite of the distributive property. In fact, if you wanted to check your answer, you could distribute and you should get the original expression that we were asked to factor. So you could think of GCF factoring as the exact opposite of the distributive problem, right? Where you're figuring out what was distributed, take it outside, prepare parentheses, divide it out of every term to see what the other term must have been.